What's up guys, this is Massey. Welcome to another video. In this video I want to deal with optimization question. It says a cylindrical drum with an open top is to be constructed using 1 meter squared of aluminum. Write an equation for the volume of the drum in terms of the radius and what radius gives the maximum volume. So we have the drum, open head, so surface area will be pi r squared plus 2 pi r h, and we made it out of 1 meter squared of aluminum. So pi r squared plus 2 pi r h is going to be equal to 1 meter squared. It says write an equation for the volume of the drum in terms of radius. So we can say two pi r h equals to 1 minus pi r squared. H will be 1 minus pi r squared divided by 2 pi r. So volume is gonna be pi r squared times h. And instead of h I can put this one. So it's gonna be pi r squared 1 minus pi r squared over 2 pi r. Pi and pi cancel out, r squared and r cancel out. We have r times 1 minus pi r squared divided by 2. That's going to be the volume in terms of radius. And what radius gives maximum volume? We need to find the derivative with respect to r. So that's going to be 1 over 2 times derivative of r with times 1 minus pi r squared plus r times derivative of 1 minus pi r squared, which is negative 2 pi r. That's going to be 1 minus pi r squared divided by 2 minus pi r squared equals to 0, because for optimization the derivative is going to be equal to 0. So we have 1 minus pi r squared divided by 2 equals to pi r squared. So 1 minus pi r squared equals to 2 pi r squared. And then we can say 1 equals to pi r squared plus 2 pi r squared, which is going to be 3 pi r squared equals to 1. R squared is going to be 1 over 3 pi. So r will be square root of 1 over 3 pi. That's going to be the radius when we have maximum volume. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.